Hello everyone, in this video I'm going to review techniques for proving identities. In pre-calculus, one of the things we do is we prove identities such as the one shown here. We try to make one side of the equation equal to the other. We don't want to treat it like an equation. In other words, you don't want to think of it as, well, I'll multiply each side of this by secant of x. Even though, yes, we could. The idea with these proofs is to take one side, doesn't matter which, and keep manipulating it so it looks like the other side. Generally, it's easier to start with the more complex side. So when I go through these are just one way of doing it. I try to do one of the more efficient ways. I try to be as quick and simple as possible with these, because that's usually the easiest thing to do. And again, with proofs and identities such as these, you want to remember that in addition to the fact that there's more than one way of doing it, you also want to remember that there's not necessarily one particular algorithm that we can follow. I can't always say, first do this, then do this, then do this. There's some generalities that I'll go through, and I'll try to mention as I'm explaining this. But keep in mind that everyone might approach it a little bit differently. So for starters, let's look at this one. I want to make secant of x minus cosine of x over secant of x equal to sine squared of x. Now there are several ways of doing this. One way that I like to do, especially when I have a fraction like this, when I have two terms in the numerator and one term in the denominator, I want to see if I split it into two fractions, would that make things any easier? So let's see. If I split my left side into two fractions, I'll have secant of x over secant of x minus cosine of x over secant of x. Now what I want to do is, well, on the left I can say, well, that simplifies to 1. Now, using the word secant, cosecant, cotangent, etc. can be confusing because we don't use them as often as we do sine, cosine, and so on. So let me redefine this by saying, since we know secant is 1 over cosine, this is the same thing as saying cosine of x. You know what, let me emphasize this by changing my color. So a little side work that I'm doing, I have cosine of x over 1 over cosine of x. So this became this in red. Now if I look at it in this sense, I can rewrite this so that this division problem as a multiplication, meaning that it becomes cosine of x from the numerator times the reciprocal of this denominator, which is cosine of x over 1. So this will leave me with, now I have cosine squared of x. So again, my cosine of x over secant of x is redefined as cosine of x over 1 over cosine, based on my definition of secant. Using my rules of division, I can make this cosine of x times cosine of x over 1, and hence I'll get my cosine of x squared. Now my goal is to still make this look like sine squared of x. So now we want to look to see, is there a identity, for example, that I could use for this side? I'm still on my left side. If you recall, one of our identities is our trigonometric identity. The most common one is sine squared of x plus cosine squared of x equals 1. We might think, well, is there any way that I can match this expression based off this equation? I say, well, if I subtract cosine from each side, I'll have sine squared of x equals 1 minus cosine squared of x. And so what that allows me to do is, now that I have a matching part, according to my identity, sine squared of x is equal to 1 minus cosine squared of x. So let me make a substitution. So now this becomes sine squared of x, and since that is what I want it to equal to, then I'm done. So this is one way of doing this problem. Again, again, and I'm speaking in general, as general as I possibly can. From this, we can say, from the original one, I say, let me see if I can split this into two fractions and see if that will make it any easier. You could have also, from the beginning, changed your secant into terms of each of them 1 over cosine, and gone from there. Again, there are multiple ways of doing it. This way I liked, when I split it, I was able to make my first term a 1, my second term reduced to a cosine squared of x, use my identity, 1 minus cosine of x became sine squared of x, which is what I wanted.